Good afternoon. Welcome to the chapter on graphing of trigonometric functions. Now, what are trigonometric functions? Examples of trigonometric functions are sine, cosine, tangent, cotangent, secant, so on and so forth. Now, before we learn how to graph a trig function, we must learn about graph transformation. Now, we must learn how to transform a graph f of x to a f b x plus c plus d. Now, each of these alphabet will do something to the graph. Now, b and c will give a horizontal transformation. All right, horizontal transformation. A and D will give a vertical transformation. Now, don't be so bothered about by this term horizontal and vertical. Later on, I will explain further. Now, B and C, I would like to call it the x transformation of x, and this is the transformation of y. But before I explain what does each alphabet means, now let us know what is a function. Now, I'm not giving you a robust definition, but I will giving you something intuitive, all right? Let's say you're in Sec 3 or Sec 4, this word function may sound a bit bombastic or maybe a bit scary to you. All right. In simple terms, a function is like a machine. For example, you have a machine here, a vending machine. You put in $1 and what comes out is the real thing, and that is Coke. So this machine, all right, is called a function. This is called a function. All right, this is not a robust definition, but just give you an idea. Okay, this is the input. All right, this is called the input, or sometimes they call it domain. The output, all right, they call it, this is called the output, or sometimes they call it the range. Now, so what is a sine function? All right, a simple sine function will be something like this. All right, you put in x. All right, this is a sine function, sine x. Then it comes out sine x. Okay, simple. Now, but today we are going to learn how to transform a sine x to something like how you transform sine x to an example of 3 sine x plus 1. All right, this 1 is the d and this a is the 3. For example, how are we going to transform? Now, let's look at it, what it means. Okay, now I use this example again. All right, now you put in x, you get sine x. Okay, and then what happened? You multiply it by 3. All right, so every value of sine x, the output you times 3. So you got 3 sine x. And then you add 1 to this output. So you have 3 sine x plus 1. Okay. Now, why I would like to call this the y transformation? So it's like, you put x into sine x, then comes out the result sine x. Sine x is actually y. Then you times 3 to the output, so you 3 times y. All right, then you plus 1 to it. So for me, I like to call it the y transformation. I think it's more intuitive that way. Now let's look at it, what it means graphically. So let's say this is the graph sine x. Okay. Now this is 0. This is 180. And this is 360. All right. This value here is 1. Here is minus 1. Should be draw a bit lower, but it's okay. So for whatever x I put in, all right, let's say I put in this x, all right, this is the x, and I get this output, this is sine x. All right, I put x in, I get sine x. Now, let's say I times 3 to it. That means the output, the value, whatever value, I'm going to times the output by 3. So let's see what happened. Now this point doesn't change because 0 times 3 is still 0. So is this. Now 1 times 3, you will get 3. So this point will come somewhere here. Minus 1 times 3, you get minus 3. So this point comes somewhere here. All right. So your new graph, and so are the the other points. All right. You just multiply by 3. So your graph looks something like this. Okay. So this graph is 3 sine x. 3 sine x. Now after that, you're going to add 1 to it. You're going to add 1 to it. So what happened to this graph? This graph will be pushed up by 1. Okay. Now 0 here will becomes 1. This is 3. So now becomes plus 1 becomes 4. Alright, 0 will becomes 1. So this point is minus 3, you plus 1 become minus 2. Alright, this point is here. So now the graph will look something like this. Alright, I use dotted. I think it's easier to see. Alright, so this distance here, this distance is 1. Alright, this is also 1. No, sorry. This is 1. Alright, this distance is 1 unit. And this is also 1. This is also 1. 1 unit. Right, because it's being pushed up by 1. So the distance between the blue, the yellow, or the orange and the blue is 1. Alright, so this is 1. Alright. Now, so now that we have drawn the graph, now let's look at what does A do to the graph. Alright, now roughly you get an idea. Now what will A do to the graph? Now, A will stretch the graph by a scale factor of A, all right, parallel to the y-axis. All right, A stretches the graph by a scale factor of A, all right, parallel to the y-axis. right? Now, what will B, all right, well, or rather, what will D to the graph, do to the graph? Now, before I go to D, now what happens if A is less than, is between 0 and 1? You'll find that it compresses the graph by a scale factor of A. Let's say it's half. All right, then it compresses by a scale factor of 2. That means it just, everything will be pressed down towards the y-axis. Any point on the y-axis will, any points on the x-axis will not change the value, its value. Right, so you press down this way. Okay? All points on the x-axis remains unchanged. Now, how about D? D will shift the graph up or down. Up is D is greater than 0. This one down means smaller, that the D is smaller than 0. All right. Shift the graph up by D modulus, that means I take the positive value of D, modulus D units. All right. Parallel to the y-axis. Okay, D shift the graph up or down by D units, all right, parallel to the y-axis. All right. Now for A, what happens if A is equals to minus 1? All right. Now, what will it do to the graph? If A is equals to minus 1. Now, what will it do to the graph? If A is minus 1, then, now you look at this sine graph, the one in red. All right. If I times minus 1 to it, all right, that means becomes minus sine x. So whatever value is positive is being flipped. It becomes negative, but the same numerical value. All right. That means if it's 0.8, now become minus 0.8. If this is minus 0.4, it becomes 0.4. So if A is minus 1, all right, the graph is reflected about the x-axis. All right, get it? Now we have more or less covered vertical transformation. Now we shall move on to horizontal transformation. Now we have come to horizontal transformation. Now let's just recall what we learned in vertical transformation. Let's say we want to transform the graph f of x to afx plus d. So you put x into the function, you get fx, and then you multiply it by a, you got afx, and then you plus the output, a d to the output, so you got afx plus d. Now, what is the purpose of me telling you this is that please take note that A and D make changes to the output. A and D make changes to the output. Now, for horizontal transformation, that is for B and C. Now, to look at it is a bit different or against intuition. Now, how we look at it is what changes must be made to y, must be made to y, to x, sorry, x, right, must be made to x for the same output, okay. What changes must be made to x for the same output? Now let me illustrate to you what do I mean by that. Now let's say you have a function f of x, all right? So you have this f of x. Now I put x1 inside. What will I get? Comes out will be f x1. Okay. Now there is another machine that is that's related to this. All right. Now the machine is f2x plus 30. All right. f2x plus 30. Now, so you want to get the same x1. All right, you want f x1. So what must you put inside? All right. Now, you put inside x, but you want the output to be x1. So what must you put in terms of x1? What is the value of x? Now, if you look at this, you can say that 2x plus 30 equals to x1. All right. So x will be equals to x1 minus 30 divided by 2. Okay, x will be equals to x1 minus 30 divided by 2. That means you must put, all right, x1 minus 30 divided by 2 into the input, and then you will get fx1. Right, that means you put x as x1 minus 30 divided by 2 into here, and then you will get fx1. Now, so what does it mean graphically? Let's look at this x1 minus 30 first. Now, this graph is sine x. Okay, this is sine x. Now, let us draw sine x plus 30. Now, that means for the same value of y, all right, what values of x must I put in? Because of plus 30, all right, because of plus 30, now I no need 30, I can put 30 less. So 0, last time was 0, do the job. Now minus 30 will do the job. Okay, last time 90 will do the job. Now 60 is good enough because you plus 30 to it. Okay, so your graph will be, maybe I use a different color. All right, so maybe it will be here. Okay, so this distance here is 30. All right, so you shift 30 to the left. Then look at the equation plus 30. You feel that it should shift to the right. No, it should be shift to the left because of plus 30. Now 30 less than whatever input I put earlier is good enough to get the same value of y. So the graph must shift to the left by 30. Now, what does 2 do to the graph? Now, because of divide by 2, so the graph will be squashed. All right, we'll move towards the y-axis. Now, any point on the y-axis will not change because any point on the y-axis, your x is 0. Or even you 0 divided by 2, it is still 0. So what does the rest of the points means? That means this distance, all right, will be half. Originally this was d. Now it becomes d over 2. So this point will come to here. Okay. Now will be pushed towards the graph. This point will be here, whereas this point is unchanged. So your graph here will look something like this. Alright. Now this point here is somewhere here. Alright. If we shift it, it will be somewhere here. Alright. You should look at the red graph. This is big half. So it comes down. Now this is 150. If you half it, all right, this point here will comes to this point. Okay, then this point here, this distance is half. All right, this distance is d. All right, because you divide by 2. So now this distance here becomes d over 2 for the same y. Okay. Now this point here, you half it will be somewhere here. So it goes something like this. Right? Now you find that the period originally was 360. Alright, now becomes 180. Now there's one point which I hope I bring to your understanding. You look at this, all right, 2x plus 30. What did we do first? We shift the 30 first, all right, instead of the 2. Okay. Now the reason being, because when we do this transformation, all right, what we do first, we use algebra, all right, we minus 30 first before we divide by 2. So as long as the transformation of x is concerned, you do c before you do b. Whereas for transformation in y, all right, this is the y, all right, the vertical transformation, all right, what do we do first? We do a before we do d. Okay, so you have to follow the sequence. Now let's write out in brief what does B and C do. All right, let's start off with B. All right, B will compress the graph, compress f of x by a scale factor of B. All right, parallel to the x-axis. Okay, now if B is greater than 1, what will happen? If B is greater than 1, all right, implies stretches, all right, stretch. Okay, now there's something here, points on the y-axis doesn't change. All right, points on y-axis remains unchanged. All right, this is the short form for unchanged. Okay. Now, how about C? C will translate the graph X C units to the left. Right? In this case, for C greater than 0. C greater than 0. Now, if C is smaller than 0, all right, C greater than 0. If C is smaller than 0, that means translate to the right, translate the graph, everything the same, to the right. Okay? Before I start with question number 1, I would like to highlight the word, what is a periodic function? A periodic function is one that repeats itself in a fixed interval of time. All right. Now, take for example, if I write a function f of x is equals to f of x plus a. All right. That means, let's say this, what happens if this is 2 pi? That means every 2 pi, it has the same value. Take for example, if this is, maybe I change it to 360. Maybe you all can visualize better. All right. If I use 360, this is f of x. Now that means f 30 degrees will be f of 30 plus 60. f10 will be equals to f10 plus 360. That means for every 360, all right, whatever value here, then you will take the f of x. That means f of x will be equals to fx plus 360. All right. Now, if this is 10, you take this point, then 370 will also have this value. Now, when this is 20, all right, then 360 plus 20 will be 380. All right, will be here. All right, 380. Now, maybe I just extend the axis a bit. Now, if this is 30, it takes the value here. Take for example, now 360 plus 330 is 390. All right, 390, it takes this value. So you can see it repeats itself. All right. Now, for sine and cos has a period of 2 pi or 360. For tangent, its period is 180. Okay, to draw this graph, we do it by graph transformation. Let's draw the graph y is equals to sine x first. Now let's say this is 360. This will be 180. All right. Now your sine graph looks something like this. Okay. Now first, we transform this graph y is equals to sine x. Now, we can do the transformation in x first or the y first, it doesn't matter. Okay. Now, but within y, all right, we must do 5 first, all right, before we do 2, all right. But we can choose to do the x first or the y first. Now, let us do the y first, all right. Now, you want to transform sine x to 5 sine x, okay. Now, when this is a 5 here, so it stretches the graph, all right. The original was 1, and this is minus 1. Now, it stretches the graph parallel to the y-axis by a scale factor of 5. So it was 1, so now becomes 5 and minus 5. All right, this is still the same, it is still the x-axis. Then let's transform it to 5 sine x minus 2. So we will move the graph down by 2. Now, this was 5. If I move it down by 2, that means, maybe I just use this. It will become 3. All right, this will become minus 7. Okay. Now, this was 0. Now become minus 2. Okay. So 0 is somewhere here now, all right? Okay, somewhere here. We'll do the x-axis later. Now we do the transformation for the x. So this now becomes what? Let's transform this graph to sine 2x minus 2. Now, what does this do to the graph? Do to the graph? It actually compresses the graph with a scale factor of 2. By a scale factor of 2. So instead of 360, the period, it now becomes 180. All right, then this will becomes 90. Okay. Now, this is no longer the x-axis. Okay. Now all this you can erase, right? You can erase all this. Maybe I just cross it out for you. Okay. I will not, the first sum I will not erase it so that you know how I do the transformation when you make reference to it. Now, so where is 0? 0 will be somewhere here. Alright, so now I just draw the x-axis. Okay. Now, for that, now you are asked to draw for x is equals to 360. This is only 180. So what you do is you repeat this graph. Okay, you repeat this graph. All right, you draw another cycle. Now, due to space constraint, I would, oh sorry, this shouldn't be so high up, huh? It must be of the same level. So it just repeats itself. Now you find that the original sine graph, let's say sine x, has a period of 2 pi. Now because of 360, because of these 2 here, for this graph, it will have a period of 180. All right. Now, let's move on to question 2. Question number 2 you are asked to sketch this graph y is equals to 3 sine 2x for this set of value of x. And after that, you are also asked to draw the equation of this line. Now let's begin by drawing the sine function first. Now as you know, sine function has a period of 2 pi. Now so this is how the sine function looks like. Okay, and this is a typical sine graph. You have 1 and minus 1, and that is, it has a period of 2 pi. Now because of these 2, what does this 2 do to the graph? It compresses it, right, by a scale factor of 2. So instead of 2 pi, it now becomes pi. If this is pi, this is pi over 2. All right, this will be pi over 4. Okay, and this is 3 pi over 4. You can write that down. Now, next we look at this 3. 3 actually stretches the graph parallel to the y-axis by a scale factor of 3. So instead of 1, now becomes 3. Alright, that is how we transform the graph. Instead of redrawing, sometimes we just rename the axis, alright, the coordinates. We just change it accordingly. Okay. Now let's draw this graph. Y is equals to minus 2x over pi plus 1. Now, let's say when x is equals to pi, y will be equals to minus 2 pi over pi plus 1. Now why I choose pi? Why do I choose pi? Because I see pi as denominator and you have an x at the numerator. So in order to work with a decimal 3.142 whatever, so you need to key in the calculator. So I conveniently choose x as pi so that I can cancel it away. Alright, just like this, and you got y as minus 1. Okay, so where did it cut the y-axis? It cuts the y-axis at 1. So if this is 0, 1 will be here, 2 will be here, let's say, so it cuts the y-axis at here. Now, how about let me just draw this. This is minus 1, so let's say this is minus 2. So when x is pi, alright, it cuts the y is minus 1. So it will be here. Okay. Now you can just join it. Now look at this. These two distance is the same and then the same height. So it should cut. The line should cut through pi this point too. Alright, because these two height is the same and then this distance is the same. Alright. So this line is y is equals to minus 2x over pi plus 1. So the last part of the equation of the question is that it asks you for how many solutions are there for this equation. So you have 1, 2, and 3. Alright, the answer is 3 solutions. Alright, for that, let's move on to question 3. Hi, question number 3. Now in question 3, you are asked to sketch y is equals to minus 2 sine 2x minus 30. Now you can do the y transformation first or the vertical transformation first or the horizontal transformation first. Is either one will do, all right? But for today, I'm going to do the x transformation first. That means this part first. Now, there's two ways to do. One way is to do the 2 first. The other one is to do the 30 first. Now, let's see now how to do the x transformation as to why we do the 30 first and things like that. But if you do the 2 first, you must do some modification to it. Now, personally, I prefer to do the 30 first. But let's look at what we learned earlier as in the transformation of x. Now, the transformation is for x is that for the same output, what values of x must we put into the new function for the same output? Now, let's say we put x1 into the sine function. All right, we get sine x1. Now, so for sine x1, what must we put into sine 2x minus 30? Now, so you want this part to be equals to this, all right? Now, for this, that means now you put x into sine 2x minus 30, and you want it to be sine x1, all right? Now, that means x1 must be equals to 2x minus 30. Okay, so we must find the value of x, all right? What values must we put in? So you find that maybe I just move it across to this side, it's easier for you to see. So I rewrite 2x minus 30 equals to x1. All right, so 2x will be equals to x1 plus 30. And x is equals to x1 plus 30 divided by 2. Okay. Now look at this. What if I want to transform? What do I do first? I do 30 first. All right, I do 30 before I divide it by 2. So I'm going to follow this process. So your y equals to sine x graph. Let me just draw the y equals to sine x graph first. So this is 360. All right. So you have 180 here. So your sine x graph looks like this. All right, this is 1 and minus 1. Okay. Now let's do the minus 30. All right, so we must move the graph to the right by 30. Okay. Now look here, we have to push it to the right. All right, so what values of x must we early because of this minus 30, so we must compensate it by putting an extra of 30. Now just remember, intuitively you feel that this graph is for x is against intuition. It's minus 30, you feel that it should be moved to the left, the graph, but actually it moves to the right. All right, so anything that is transformation for the x is against your intuition. So you have to move the graph by 30. Now instead of shifting the graph by 30, I'm going to change the x-intercept. So this instead of 360 will now be 390. Now instead of this was 180, so 180 plus 30, this will be 210. Now so 210. This instead of 0 will be 30. All right, so the y-axis is actually shift to the left. But I put it like that as it is now. Now we have finished doing the minus 30. Now let's do the 2. 2, what will happen to the graph, alright, if it is, the x is multiplied by 2? Now you find that it compresses it by a scale or scale factor of 2, alright. It's against intuition, alright. So you look at this, it actually divide by 2. So it actually compress the graph by a scale factor of 2. So instead of 390, this will become 195. Alright, this is 105. Okay. So let me just erase this. So this is 195. Alright. This is 105. And this is 15. Okay. Now, how about these two? Alright. Now, we multiply by 2. So this coordinate will be 2. And this will be minus 2. But there's a minus sign here. So we must flip the graph. So how does your new graph looks like? So after being flipped, your graph will look like that. Okay. Now, and this coordinate will be changed to minus 2. And this will be 2. You see, instead of like moving the graph, sometimes I just change the numerical value. It's much easier that way. So where's the axis now? The axis is somewhere here. Okay. That's how the new graph looks like. Now let's look at another way of doing this sum. The other way is we will attempt with the 2 first. Alright. Now let's draw the graph y equals to sine x. Okay, comes down, then goes up. Alright, so y equals to sine x has a cycle of 360 degrees. So this is one cycle. And this value is 1 and maybe minus 1. Alright, and then here is 180. Now, these two actually compresses the graph. Alright. So instead of us having to redraw the graph, we just change the x coordinate or the x-intercept. So this will become 180 and this will become 90. Okay, this is still 0. Now, let's look at this equation. Now, this equation can be rewritten as x1 over 2 plus 15. There's a shortcut to this. Instead of having to do all this long working, if we want to do the 2 first, normally what we do is we do a factorization. Alright, it will be equals to, we take the 2 out, what is inside will be left with 2 into x minus 15. So these 2, whatever the transformation of x is always against intuition. You look at this, you feel that it is being stretched, right, by 2, by a scale factor of 2, but actually it is being compressed. Now this one you feel that it is being shifted, you need to shift the graph to the left by 15, but instead you need to shift to the right by 15. So again, let me just summarize for you. So we just factorize the 2 out, alright, that we apply, we do the transformation of this, followed by the transformation of this. So this, instead of being 0, it is now 15. All right, this will be 105. Let me erase this. This will now be 105 because 90 plus 15 is 105. And what will this be? This will be 195. Now, if this is 15, we need to change the axis as well. All right, now, so the axis will be shifted to the left. All right, now let's apply minus 2. All right, we multiply by minus 2. So you'll find that this part, instead of 1, now becomes 2, and this is minus 2. All right, now because it's negative, so we need to flip the graph. All right, we need to flip the graph. So now your graph will look something like this. All right, because of negative. Maybe this is this one I should draw a bit lower. Minus 2. All right. For that, we have come to the end of question 2, which means also the end of this video. Now, if you like our video, please subscribe